Yes, hello friends. So this is the video tutorial for today's Leetcode problem of the day 3432 count partitions with even some difference. So the question says you are given an integer array nums of length n. A partition is said to be is defined as an index I where I is between 0 to n minus 1, splitting the array into two non-empty subarrays. So this is important that both the left partition and the right partition have to be non-empty. Left subarray contains 0 to I indexes, right subarray contains I plus 1 to n minus 1. Return the number of partitions where the difference between the sum of the left and the right subarray is even. So let's write down the first test case. 10 10 376. Okay. So this is the first test case, that is 10 10 376. Right. So what are all the partitions here? The first partition is, okay, give me 1 second. Yeah. The first partition is, yeah, the first partition is 10. Okay, yeah. The first partition is 10 and 10 376. Right. The second partition is 10 10 376. The third partition is 10 10 376. And then last partition is 10 10 376. Right. So that is basically partitioning here, partitioning here, partitioning here, partitioning here. Because both the left and right parts have to have some value, right? Or must not be not empty. Now, what would be the left sum? Here would be 10. The right sum here would be 10 and 20, 26. The difference would be 16. This difference is even. So this is a valid partition here. Left partition would have some 20. The right partition would have some of 26. The difference would be not 26, actually 16, right? Yeah, 16. The difference would be 4. Again, this is valid. Here it would be 23, and this would be 7 and 6, and this is 11, or no, 7 plus, yeah, this is 13. So here this is 10, this is also valid. Here it is 30, yeah, 20 30. This is 6, so this is also 24, this is also valid. Okay. So all of the partitions are valid, so the answer is 4, and yeah, the answer is 4. Now, yeah, that is like dry running this, but how can you solve this? See, what we need is left sum minus right sum, or the absolute of this has to be even. So this has to be even. Now what we can do is see, what is lefts, we can iterate over the array, we can maintain our left sum, and whenever we are at I index, we'll do left sum plus equals to arri. So that is, we are picking the ith index in the left part, or we'll adding it into left sum. And what would be our right sum? Right sum would be just total sum minus left sum, right? So we go over all the indices, we calculate a left sum, we calculate a right sum, we calculate a difference, and check if it is even. If it is even, then we'll do answer plus plus, else we'll just keep the answer. So this would be a simple O of n solution. Right? A pretty simple solution. Let's check the code now. Okay. So as I said, we'll calculate the total sum. If you do not know, there's an accumulate function. This will accumulate your array and give you the total sum of this. So I just calculate this. Obviously, this is an O of n looping through the array, right? So this is O of n, and we'll also do O of n competition here. So time complexity is O of n. Okay. So I calculate the size of the array. I calculate the left sum, and I create an answer variable. Then I go over all the indices in the array. As I said, will add it to the left partition. I'll add ls plus equals to nums I. Then I calculate the right sum, that is total sum minus left sum. I calculate difference. Difference is absolute between left sum and right sum. If difference is even, I increment my answer and return answer. Yeah. So this works. Thank you for watching. Okay, I do not know why this is happening, but yeah, thanks for watching. If you were able to understand anything, give me a like and subscribe. All of those things. Bye bye.